All right, day 56. This is the second day of exponent laws and expressions, and this should be a fairly short lesson, fairly short set of homework, so this might be a little bit of a catch-up day, I hope. The goal for the 3-minute review is to evaluate expressions involving exponents. And we see we've got x's and y's and z's and stuff all over the place. Um, it asks us to simplify, substitute, then evaluate. Um, and notice that down here, there's stuff that can happen before we substitute, right? The simplify part. Can we simplify this? Well, I suppose we could use the negative exponents uh, rule, right? So this is 1 over x to the exponent y. Now, that might have been a bad thing to do if it happened to be that y was negative, because then it would flip up into the top. So for instance, uh, if x is -2 rather, but if y ended up being -4 instead of +4, then we could have made that a positive and then not had to flip anything. But it turns out that this is going to be just a fine way to do it. X, the base, when I take out the x, it kind of leaves a hole. I'm going to fill it with what x is equal to, -2. Y is 4, and then -2 to the exponent 4. -2 times -2 times -2 times -2 is going to be a positive 16. Okay, next. This is one of those examples where instead of pounding something into a calculator, let's use an exponent rule and simplify this. Because there's no plus in here, the 3 applies to everything inside the bracket. So this is 4 cubed and then z cubed. Well, 4 cubed, you can do that on a calculator in your head, is 64. Z is -3 cubed. And now it's time to reach for a calculator. 64 times -3 cubed is -1728. Now notice how silly it would be to start putting stuff into this to substitute first, then solve. We talked about solve and substitute, substitute and solve. This one, if we substituted first, these numbers would become huge, right? -2 to the exponent 4, 4, all these, we'd have to do 6 calculations, multiply it all together, divide it at the end, when really, if we were smart, use our exponent rules, and it's kind of like we got 3 little exponent questions in this one, right? And look there, the z's actually cancel out, right? Z squared divided by z squared is z to the exponent 0 or just 1. Subtract the exponents. 4 subtract 3 is just 1. Subtract the exponents. The exponent on the y, even though it's not written in there, is an implied 1. Just like we didn't have to write the 1 there. There is a 1 there if we need to do some operations. 1 subtract 3. And then now this isn't so bad. I'll substitute this now and see what happens. -2 to the exponent 1. And I've got, what was it? What was y again? 4. 4 to the exponent -2. And I'm still not going to use a calculator, because watch. 4 to the exponent -2 is 1 over 4 squared. Still no calculator. 1 over 4 squared is 16. Now I've got -2 over 16, because remember, fractions, whole number there is over 1, and then I multiply across. -2 times 1, and then I can cancel this and get negative on top 8, -1/8. Similarly here, there's lots of stuff to do. I see this first bracket, the 3 applies to everything inside the bracket. That's 2 cubed, y cubed, and z cubed. The y has got a -2 on it, the z has got a -5 on it, and there's lots of work to do here. But if I'm patient, maybe some stuff will become simpler, right? Instead of starting to reach for the calculator, let's do a little work here. This maybe I'll evaluate. 2 cubed is 8. But now everything on the top is multiplied, right? So when I see the y powers, I can add those exponents. Add those exponents, I'm just left with y3 plus negative 2. Well, that's just 1, isn't it? That's actually just 3 minus 2, which is 1. On the z, let me get the different color there too. For the z powers, add the exponents. Now I'm left with z to the exponent 3 minus 5 is negative 2. And on the bottom, go back to green here. I'm just going to write that down for now. But I can see I still have, after I've figured out the top, and it's getting better, right? Already, if I substituted better, substituted in now, it would be better than if I substituted in earlier. Well, 8 divided by 4 is just 2. Subtract the exponents. 1 subtract 3, that's minus 2. Negative 2 subtract z, the exponent on z is an implied 1 there. Z to the minus, well, that's minus 3. And it's getting better all the time. Now, notice here, what's my z value? My z value is net minus 3, but it's in the base. I can actually simplify this. If I wanted to write it as a positive exponent, this would be 2 over y squared z cubed. Now, if I substitute, it's actually a pretty easy thing to do, right? Y was 4. Take out the y, put in a 4. Take out the z, put in a, what was it, a minus 3? Yeah, minus 3. And that can go into your calculator all in one step. Be careful, though. 2 divided by big bracket, and then a bunch of exponents, and you get exactly on the bottom, you get negative 432. If you cancel that, you'd get a nasty decimal, but it wouldn't be so bad. You get 1 over, and I'm going to write the negative out front, 216. That's the 3-minute review. 3-minute review that took what? How long? 7 minutes. Well, sorry about that. But the rest is just one little example. Now, what I would suggest, because this is kind of, this is just an expression, and we're going to fill some values in, but it's about something that's called a Ponzi scheme. And this video, which I've attached to the calendar, is a background about Ponzi schemes. And obviously the dude's name wasn't Ferdy Madoff, but there was a man that was arrested and made, you know, billions of dollars, and he was basically just robbing people because of a Ponzi scheme. And this happened not very long ago, and there was a lot of influential Americans who lost all of their, not all of their money, but a lot of their money because of Bernie Madoff, not Ferdy Madoff, Bernie. I can't remember the dude's name. Just let me look him up. No, I was right. I just Googled him. There he is. It's Bernie Madoff, and he got arrested not very long ago for basically having a huge Ponzi scheme. All these rich people sort of gave him this money, and they got good returns early, and then basically he just stole from them. And hopefully you watch that video about the Ponzi scheme. It's got nothing to do with math, but it does got to do with the next example that we'll talk about, which is a bit of fun. So Ferdy Madoff is involved in an illegal but successful Ponzi scheme. His investment grows according to this formula. And we're going to talk about exponential models. This is, notice the unknown is in the exponent. That makes an exponential model, where m is the number of months gone by. How much did Ferdy start with? Well, one way to think of this is m equals 0, and then just calculate it, right? M equals 0, well, put this into the calculator, but this, anything to the exponent 0 is 1. So it's 250. Well, that makes complete sense, because when we were talking about exponential models, that number that was in front of the base, this is the base, and I can see because it's more than 1, it's a 1 plus r or 1 plus I base, that it's a growth model, and A is the initial value. So he started with, what was it, $250? Doesn't say the how much that, let's say 250. How much did Ferdy have in 8 months? Well, in 8 months, M equals 8. And now this is the sort of thing where we're not using exponent laws, right? We're just getting used to using our calculator and putting this into our calculator. So it would be 250 times 2.44, then your exponent button. That one, or if you're using a graphing calculator, it looks like that, or on some other calculators, it looks like that. 8, and then equals, and you should get about, now what is that number? Well, you kind of pause for a breath and a word every 3 digits. So it's $314,093.26. 8 months go from $250 to $300,000. Now, I'm not saying this is how much this guy made. I completely made up that formula. But you get the idea of exponential growth. Very, very quick. That's it for the video. Homework short. Have fun.